This video is about reducing fractions. Reducing fractions can also be called putting fractions in lowest terms, or it could be simply said as simplifying a fraction. So this is how we get from a fraction like 2/4 to an equivalent fraction of 1/2. What we're doing when we're reducing fractions is we're going from a larger denominator to a smaller denominator. That's the idea of reducing. There are two methods for reducing fractions. The first is the greatest common factor method, and the second is the prime factorization method. We will be going over both and talking about the things that we need to know how to do in order to do each of the methods. We'll start with the greatest common factor. The largest factor that two or more numbers have in common is what a greatest common factor is. Now I've starred the word factor up here because we need to realize that a factor is a part of a multiplication problem. So if I were to say 2 times 4 is equal to 8, the numbers 2 and 4 are the factors and 8 is a product. So that is what a factor is, a part of a multiplication problem. So we're going to find the factors of 24, and I really should put in here all factors of 24. So the process that we're going to do in order to find all the factors of 24 is I'm going to put 24 down here. Now this is only one method. There are a couple of methods, but I am only going to do this one. So I'm going to say, okay, 1 times 24. That will give me 24. And then I'm going to put a comma on each side, and I'm going to say 2 times what equals 24? Well, 2 times 12 equals 24. And then the next one, I put commas, and I'll say, okay, does 3 go into 24? Yes, so 3 times what? And 3 times 8. And then I'm going to make commas again, and then I say, does 4 go into 24? Yes, 4 times what? And that's 6. And then I'll put a comma again, and then I say 5. Does 5 go into 24? No. And then I would be going on to 6. And since how 6 is already written down, I've done something that I call meeting myself in the middle, and I know therefore I'm done. So I start with the smallest number that goes into 24 and find its other factor. Then the next number, 2, that goes into 24 and its other factor, and 3 and its other factor, and 4 and its other factor. And then my next number to do would be 5, which doesn't go, and then 6 is already down, and so I'm finished. And so those are all the factors of 24. Now once I know how to find all the factors of the number, I also need something else called the fundamental theorem or principle of fractions. This principle or theorem says that if I multiply or divide both the numerator and the denominator by the exact same number, and this number must be non-zero, then the fraction you get will be equivalent. So in other words, if I start out with a times b and I multiply it by some c, which isn't 0, then I get a fraction that was equivalent to the original a over b. I could change these multiplications to divisions and they would be the same exact thing. And that's how we're going to reduce, is by dividing. Now when we multiply, we're doing something called building a higher term, which we'll need later as well, but we're going to be doing the division side in order to reduce, because we're going to be making those smaller denominators, so we have to divide to do that. Right, so we are going to reduce 18/24 using this GCF method. So finding the greatest common factor starts out by looking at all of the factors of the numbers. So we're going to get 18's factors and 24's factors. Well, we already have 24's. So let's do 18. 1 times 18. 2 times 9. 3 times 6. 4 doesn't go into 18. 5 doesn't go into 18. And 6 is my next number. So there they all are. Now let's rewrite out 24's factors. 1 and 24. 2 and 12. 3 and 8, and 6, and that's all of those. Now what we want is the largest factor that they both have in common. So the greatest common factor here, the largest one, the greatest one that they both have in common is 6. So the greatest common factor between 18 and 24 is 6. So now what we do to reduce this is we divide out the greatest common factor from both the numerator and denominator using the fundamental theorem of fractions. 18 divided by 6 is 3, and 24 divided by 6 is 4. When a fraction's numerator and denominator are separated by only one number, you know that it's in lowest terms. You, by the way, should always check to make sure that you really did get a number into its lowest terms. Now let me go ahead and summarize the steps that we did in order to find our greatest common factor or reduced fraction using the greatest common factor method. The first thing that we did was we find all the factors, right? Find all the factors of the numerator and denominator. And I'm just going to write that down in abbreviated form, num and denom, to get our GCF. And then, once we have the GCF, the second thing we do is we're going to divide both the numerator and denominator by that GCF. And then you should make sure it really is in lowest terms. And that's how we did this. All right, now let's go talk about the second method, prime factorization method. The first thing that we're going to do is learn how to do prime factorization of a number. So we're going to take a number and we're going to find the lowest prime that goes into it. Now, if you don't know what a prime number is, we should talk about that. A prime number is a number that has only one and the number itself as a factor. So that's what it means to be prime. A partial list of prime numbers, the lowest prime number is 2, the next prime is 3, the next prime is 5, the next prime is 7, the next one is 11, then 13, then 17, then 19, then 23, and there is a pattern there, but it's a fairly difficult pattern to see. But there is a math formula that can tell us those prime numbers. So you probably should know at least up through 13. Through 23 is not a really bad idea, and maybe even a little bit further than that. But if you know these at very least, it'll make your life a lot easier. So one of the things I do want to warn you about prime numbers is just make sure that you don't get to thinking that prime numbers are odd numbers, because most of them are, but the lowest prime number is not odd, and not all odd numbers are prime. For instance, 9 is odd, but it's not a prime number because it can be found as the product of 3 times 3, which makes it not prime, because the only way a prime number can be found is a product of 1 in itself. So 3, 1 times 3, that's the only way you can get it. 5, 1 times 5, that's the only way you can get it. So those are the reasons that those are prime numbers. Now, once we find that the lowest prime number that goes into the number, once we have that, then we're going to find its other prime, or that its other factor that isn't a prime, and we'll continue until we are down to just another prime number, and then we're going to write it as a product of primes. So let's actually go do that. So let's do the prime factors of 18. Now what I'm going to show you here is something that's called a factor tree. So I'm going to write branches out from 18, and I'm going to say, okay, the lowest prime that goes into 18 is 2. Divisibility rules, right? 18 is even, therefore it's going to be divisible by 2. Now I always circle my prime numbers. I don't break these down into 1 times themselves or anything else. When I have a prime number, I circle it. And that tells me that my branch has ended in a leaf. All right, now 2 will go into 18 9 times. That's the other factor. 9 is not prime. So I'm going to do that same process on 9 again. What's the lowest prime that goes into 9? Well, that would be 3. So 3 times what equals 9? Well, 3 times 3. Now you see 3 is prime, and therefore I'm done. That's where I finish. Now I'm going to rewrite 18 as a product of primes. 2 times 2 times 3. And you see, that's why I circle my prime numbers, so I can easily, oops, not times 2, excuse me. That was bad of me, times 3. That is why I circle my primes, so that I know where to go to find them. And you should always check. You should see that 2 times 3 is 6, and 6 times 3 is 18. You should always get that. Now, another way of doing this is saying 18, and then 2 goes into 18 9 times. That's not prime, so we'll do it again. 3 goes into 9 3 times, and now you see all of your primes here. That's another way of doing the same thing that I did in my factor tree. All right, so our prime factor method for reducing is that we're going to rewrite our numerator and denominator as a product of primes. Then we're going to cancel our numerator and our denominators like factors. So we're going to reduce 18/24 using primes. We've already done 18 as prime factors, so let's do 24. So lowest prime is 2. 2 will go into 24 12 times. 2 is prime, so I circle it. 12 is not, so I'll start again. 2 times 6. 2 is prime, 6 is not, so I'll start again. 2 times 3. Those are both primes, so I'm done. So now I will write 24 as a product of its primes. So 18 looked like 2 times 3 times 3. And 24 looks like 2 times 2 times 2 times 3. Let's check it out, right? 2 times 3 is 6, 6 times 3 is 18, yes. 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24, yes. Now here's the canceling part. One of these goes with one of these. When you cancel, what you get is 1. Canceling is actually division. It can only be done in a division problem. So if we have this division of this number by this number, we have this idea of dividing, but division and multiplication are related to one another. So we're doing this as a numerator and denominator. And then one of these 3's goes with one of these 3's, and those become 1's as well. Now we're going to multiply straight across. 1 times 1 times 3, which is 3. And then 1 times 2 times 2 times 1, which is 4. And you see we get the exact same answer. So those are our two methods.